All right, let's go ahead and get started. Make sure everybody's in the right room and stuff. This is Calculus 1, Math 1241, Section 009. If you'll notice my Canvas page, which I have up here for you guys, with my classes, I've actually teach two classes back to back. I've got Calc 1 Section 9 right now, and then again at 3:30 I've got another Calculus 1 class. So I decided to go ahead and post one big Canvas page that goes actually to both classes and stuff. So also, one of the things that I traditionally do with my classes is I actually record the classes. So because my classes are so large, a lot of students are apprehensive about asking me questions and stuff. So I would, record the class, so in case you miss something or other, you can go back and watch what we actually covered in class and make sure that you've got the correct answer and call it back up and stuff like that. So I've found through the years this has been very advantageous, especially for the large classes like my classes traditionally are. Just in case you wanted to know, hi, my name is Dr. John R. Taylor. Like I said, welcome to the spring semester 2018. Information. Now, I'm not familiar, I'm not sure how familiar you guys are with the famous Canvas page, but this is our platform of how we communicate with our students and stuff. And when it comes to these type of pages, everything you want to know is typically listed under modules. Now, under the home screen is where I make my announcements. So my announcements are click on the syllabus in the upper left hand corner and we'll read it before getting to class here, and also review your algebra and trigonometric skills and formulas. Also, I'll be working on the due dates and stuff like that, so nothing is due right now. And what I mean by that is, we're in the drop ad right now, so there's still people trying to get into this class, and because of that, I can't officially allow homework number 1 be due before drop ad, because you sure as I'm standing here, some poor sap's going to sit there and add my class soon after the homework set's due. Well, and then I guess he doesn't get to do it, makes a 0 on it. Well, that's not quite fair. Why he's adding my class so late, that's not quite fair either. But nevertheless, I traditionally make sure, and this is a university policy, we make sure nothing's officially due. So right now, everything is open and stuff. And we'll talk more about what it means to be open and things like that. But once drop ad is over, all of a sudden you're going to see due dates are going to be appearing and closing out on you and stuff. But again, everything on your Canvas page is listed under modules. So if I go over here to modules and wait for a second, here's the big deal. Here are our course documents. Here, a lot of things you see, but quite a few things you don't see, because this is my master thing. Our class is on Tuesdays and Thursdays. So here's our course calendar right here. So if you want kind of a day-by-day description of what sections I'll be covering, it'll be located right here. We also have, kind of a little form for you to keep up with your grade and attendance and the like. In our class, we also have preceptors, and in this particular class, we have a preceptor. It's Katrina, sitting way in the back there. She is my right hand. Again, with classes so large, I have an undergraduate assistant, and her job is to, when you can't get a hold of me, is go to her. She can answer questions almost as well as I can, and she's very, very good. She's done this stuff before, and like I said, she's a big role model. And if she's real lucky, we're going to graduate when? 2019? Oh, okay. 2030, 2040, whatever. Eventually, she's going to graduate, and then we're going to have to find another preceptor. But, she's very good, and she's met an A in all these classes and stuff. So she really knows her stuff, and she can really help you out. And she's worked with me. Was this third semester now or something like that? Yeah. All right, so we also have some on-campus learning opportunities. So UNC Charlotte is very good about trying to give you guys some support for these harder classes, STEM education stuff like calculus and physics and things like that. And for us, if I click on the information here, we have the the Math Learning Center, Math Resource Center, which is located on the 3rd floor of Fretwell, literally right across from the math department. It's what we call open tutoring, which means if you got a question, you go in there and there'll be several tables in there, and one that has 1241 snapped on it. So you go sit there and start doing some work and stuff, and when you raise your hand, a grad student's going to come over there and sit down with you and ask you what your question is, and he'll try to explain it to you and stuff like that. And then the grad student, once they answer your question, will get up and float around a little bit, and you got another question, raise your hand, and basically they're kind of open tutoring you, so you don't get them for the entire, however long you're there. You just keep raising your hand, and eventually you're back in line, and they'll come by and see you again and answer your questions and stuff. So, but that's our Math Resource Center, and here are the times and days that they are open and stuff. We also have a UCAE SI. SI stands for Supplemental Instruction, and we'll have some information about that for you guys and stuff coming pretty soon here. We also have UCAE. By the way, UCAE stands for University Center of Academic Excellence. They have a program set up for free tutoring. You're entitled to up to 1 hour a week of free tutoring. They pay for it and stuff. All you got to do is go over there and sign up. But there's a trick to it. They only have so many tutors. So it's a first come, first served basis. So this is over in Covart. And here's their little web page and stuff like that. You can go find more information and stuff. But it is, like I said, very helpful for, if you need that one-on-one individual attention. Your student funds have actually give you the opportunity to go and enjoy this. But it's first come, first serve. So, don't show up this week and expect to have a tutor this week because they're probably already taken up, but you can sign up for tutors for next semester and stuff. So, for next week and the following week and stuff like that. So, plan ahead is what we're trying to say and stuff like that. Also, we're working on our little recitation sessions that I'm working on with our preceptors and stuff like that. And my goal here, if you saw our front page, so I'm going to go back to the home page here. You notice our schedule is Tuesday, Thursdays, but I'm also trying to put in this review session thing for every Friday. Now, on these review sessions that I'm trying to put in, they are outside of our traditional class, but it's a time that the entire class, both my classes, can meet. So it's just kind of a joint effort on both my classes. And we're going to, it looks like we're going to try something or other for 3:30 on Fridays. And I'm going to get us a classroom. And, if you got questions, especially on our system, our online system of homework, which is called WebWork, it's not just the questions, but sometimes entering them into the computer is also kind of difficult. Great time to come by and ask questions about stuff like that. And my preceptors and I will be there to help out. And also, just before every test, I give a traditional homework set. The old traditional paper and pencil homework set, just to kind of give you guys a clue of what kind of test you're going to be dealing with and stuff. And usually I'm going to have those things due on that Friday, whatever the review session is, and I will take that review session and actually go over the entire homework set and record it so you can have something to study over the weekend to get you guys prepared for your test and stuff. So I'm working on trying to get some things for you guys, and honestly, all the things that I'm trying to do here is in an effort to make sure that you guys have a very successful semester, and hopefully everybody pretty much pulls off an A in this class, which is very doable if you put in the time and effort for it. So, like I said, back over here to modules. Now, this whole Canvas site, what we got here, is all the calculus instructors are actually doing the same thing. All the Calc 1 instructors, we all basically have the same site. It's called what we call in the math department the math redesign system. Now, I was one of the head faculty that was assigned to work on this thing, and here's basically the layout for you guys. Now, up here is under course documents, so you got your syllabus and your course calendar and the like. And if you go down here, right here, very, very important, where it says course requirements. The first thing you'll see under course requirements is what we call the Math 1241 notes for the spring 2018. And if you click on this thing here, what you're going to get is a packet of what we call notes. Now, what these notes are is they're half questions. All there are is a bunch of questions and a bunch of work right behind it. So you can sit there and I'll just click on this thing and actually upload it up here so you guys can see it. And these are the notes basically that I'm going to be working with you guys all semester long. And so we have a bunch of questions and definitions and stuff, but you'll see a lot of blanks in this thing and stuff. And you'll see us, basically what we're going to do is work these particular problems. And let me give you the theory behind this. Through the years, my students have had identifying problems with our students. One thing as our problems is students don't know how to take notes. I mean, in general, especially when it comes to science, they don't know how to take notes in a STEM style education course and stuff. So first thing you got to do is you got to write down the question, and then you work down the answers, and then you kind of insert your own little information about it and stuff like that. So to help you guys actually take notes in here, we do what we call half notes. I've got questions, so you don't have to actually write down the question, but there's a bunch of space in there where you are going to be writing down the answers. And here's the other deal. Myself compared to my counterparts, if a professor is not using notes, what they have to do is sit up here on the board and write down the question. Then they start working the question. You know how long it takes to write down some of these math questions, especially some of these large word problems and things like that. By giving you guys the questions that I'm all going to be asking you all semester long, I can cover more examples in the allotted 75-minute classroom time than my counterpart can do when he has to actually write up the questions, wait for you guys to copy it down, and then start working it. And the more questions that I can go over, the better off you guys will be in terms of understanding the material. So that's really the key to these notes, is actually covering a lot more questions, because the questions are already written up. You don't have to write them up. All you got to do is print this thing out and bring it to class. Okay, so that's that. Like I said, that is the big deal about the notes. And what the big deal about the Canvas site is, under modules, under the course resources, right at the top. Okay, back up here. Course resources, right at the top, you see Math 1241 Notes, Spring 2018. This is your icon. Click on it, print them out. And we got them set up so because there's like 200 pages of this stuff. So you can print out part of them if you want to, or do like I did and print out the whole darn thing and then put your hole in them and then bring it into a 3-ring binder. That's how I organize my notes and stuff like that. So, but here comes the big deal in terms of the class. Now right here, we got a bunch of prerequisite review. Now what exactly is a Calc 1 prerequisite? How did you guys actually get into this class? Well, you took pre-calculus here, or you got some kind of equivalent high school thing that got you on the placement test or something or other that got you into this thing. Now what does pre-calculus entail? Well, first thing we got here is some information about the unit circle and trig identities that you're expected to know. And what I did also is, you see right here where it says 1241 pre-section 1.2 part 1 and pre-section 1.2 part 2. I actually made a video of me actually doing the notes you'll see from class from section 1.2 of me actually going through this stuff and actually lecturing on this and reminding you, because in here we got so many different backgrounds. Some people took pre-calculus last semester. Some people took pre-calculus a year ago. Some people took it 10 years ago. Who knows? So, just to remind you of your algebra skills, because calculus isn't that hard, honestly. It's after you understand the concepts of the limits and the derivatives and the things that we're going to be doing, then you're going to have to set some weird equation equal to 0 and solve for x or something like that. And that's where most people fumble the ball. It's not in the calculus. It'll be with the algebra. So you got to meet, this class is going to keep reinforcing those algebra skills. So even before you come to class, first thing you're supposed to do is watch the part 1 and part 2 of the video. You've got a pre-section quiz to take on 1241 review, 20 questions. This is a Canvas quiz, so you'll have like 3 attempts on each question there. You have WebWork, WW is our code for WebWork. You've got a WebWork Chapter 1 review. Chapter 1 is the pre-section review, so this is the algebra review stuff. Then you got WebWork Section 1.1 and 1.2, which is more algebra. You got 3 WebWork sets of homework just to work on those algebra skills. Because here is where Calculus 1 really begins. So all this such stuff from Section 1.1 and 1.2 out of your textbook, and I'll talk about the textbook in a minute, out of your textbook is algebra review. Now, this is calculus class. My job is not to go back and teach you a bunch of algebra stuff. So I've made videos of from older classes and stuff like that to formulate basically reminding you of all your algebra skills. So Section 1.3 starts with the concept of what we call limits. And so this is where Calculus 1 really begins. And the way our redesign is set up, it comes in basically 3 parts. First part is even before you come to class, you have got to prepare. In the old days, our professors used to tell us, you got to make sure you read the chapter before you come to class and we start talking about that chapter. And problem is, it's 21st century. I tell my students, read a chapter in math. 1 out of 100 will actually read the book, and they've already made their A. You know that. So I mean, everybody, the other 99 people, nobody reads a math textbook. It's the cure for insomnia. We know that, but you're supposed to. And the reason for that is this: as a math professor, it is quite frustrating when a student comes up here and, hey, Dr. Taylor, what we covering today? Dude, don't you know? Because you're actually supposed to kind of keep up with the material and what we're supposed to do here. And in that light, you got to know what we're going to do even before we do it. So instead of making you guys read the book, I made a video. So, because you guys are 21st century, you don't read books, but God knows you'll watch stuff off your iPhones and everything else. So here is a pre-section video. Now on this video, when you watch it, you click on it, and I'll click on it and show you. You click on it, and there it is, and there's me and my pen. And I'll sit there and I don't know if the mic's set up on this thing or not. It is, but luckily it's not turned up too loud. But it's me talking about what this section's about. Most videos are about 10 minutes. Some sections are up to 20 minutes, depending on the topic matter, especially some of these word problems and stuff. I can't stand watching myself on a video, but or even listening to my own voice. But this is what the video is. And on this video, I talk about the concept. And then I do about 5 or so problems with you guys to kind of reinforce the thing. And very simple problems. But then to make sure you've watched the video and understand the concept, we make you guys take a quiz on the thing. And trust me, the questions on the quiz are the same questions that I did on the video. All I did was change a constant on them. So don't fret about how hard these quiz questions are, because they're not supposed to be hard. They are actually linked to the actual video questions that I actually covered and stuff like that. But to ensure you're actually doing this stuff and understand what's going on, you've got to do the pre-section quiz. 5 questions typically. And then once you've done that, and again, this is welcome to 21st century. We got computers basically logging in your grade and stuff like that. Then what you do is you come to class. You bring your notes into class, and we lecture on to you guys and talk about the concepts and get you guys well motivated. And again, with the pre-section video, the whole idea is I basically talk about the basic stuff. And then when you get to class, I can gloss over a little bit, and I can get deeper into harder problems with that stuff. So I can get actually harder problems and more involved problems done within our class time and stuff. And then after class, you have homework. I will assign some problems out of the textbook, but most of the problems that we're doing are even on our computer system. WebWork has a page number that you can link back to our textbook. So we're very integrated within our textbook and stuff. But you have to take WebWork. Now, this is WebWork, WW. That's our code for WebWork. This is your after-class activities. And usually after I finish a particular section, I give you about 5 days to complete the homework. And this is the WebWork. And for every section, you got the same pattern. Here's section 1.4. You got your before activities by watching the video, taking the quiz. Then you come to class, and then after class, you do the WebWork homework set for it. And occasionally, we'll give you a little hints for some of the interesting WebWork problems and stuff like that. That's just kind of helpful hints on problem number 12 or something like that. And we do it for every section. And then after we finish up section like 2.2, when you check your syllabus here, it's time for us to have a test. I'll give you guys a traditional homework set for that test that we'll actually cover, and then you'll take your test, typically the next class period and stuff like that. And we do this throughout. In Calculus 1, we cover the first four chapters of our textbook. Chapter 1, Chapter 2, Chapter 3, and Chapter 4, and we typically have a test after each chapter. Okay? Now, what most people are interested in, and if you look at this thing and scroll all the way down, you'll see this same format throughout. There's Chapter 2, before class activities, after class activities, so forth and so on, and then we're back to having another test, and then just Chapter 3, so forth and so on. Okay? However, how will your grade be determined? Well, this is what I wanted you guys to read before you guys came to class today, and that is the syllabus. And I just really put the electronic copy up here under the tab syllabus. So here I am. I am Dr. John R. Taylor. My office is in Fretwell, 335A. My office hours this semester are Tuesdays and Thursdays from 11 to 12:30, pretty much before class here, and then Wednesdays from 12 to 1:30, and also by appointment. So if you can't make those, shoot me an email and we'll make us a plan here. The textbook that we'll be using is James Stewart Essential Calculus, Early Transcendentals, the second edition, and there's the ISBN number if you don't want to buy it at the bookstore. There it is right there. Okay, and let me click over here for just a second. So here, and I'll do a full page and actually show you guys what the book looks like. This is our textbook, okay? And there are two types of these James Stewart Early Essential Calculus. One's blue and one's red. Get the blue one, okay? This is the second edition, Early Transcendentals. And here's the big deal. Now, the book is not cheap. However, I want to remind you that this book is used in Calculus 1, Calculus 2, and Calculus 3. Now, depending on what your major is, some of you guys don't need to go all the way up to Calculus 3, but most of you probably will, especially if you're engineering majors or in math majors and the like. So even though, like I said, it's a book that you have to buy, it's important, and the fact that it actually is going to cover you 3 semesters of math class. So in that sense, it's actually cost effective because it's not just one semester you use this book. You're going to be using it for 3 semesters, so take care of it. So there you go. And so there's our textbook and stuff. And like I said, would you have to bring the textbook to class every day? Typically not. The notes are going to be the most important. But between the notes, the examples in the book that we're going to be using, we do a lot of cross-tabulation. Even on WebWork, when you guys do a WebWork problem, there'll be a code in our textbook of if you want to see some more problems like this or try to get some other helpful hints that we didn't quite help you out with, then you can actually get the page number that you can actually go in the textbook and look this stuff up at and stuff. All right. Get back over here. Grades. Well, this is college, so we're on a 10-point grade scale. 90 to 100 is an A, 80 to 89 is a B, 70 to 79 is a C, 60 to 69 is a D, anything below 60 is an F. How your grade will be determined is before class activities, the quizzes is 5% of your grade. And here's a big one, WebWork, that after class activity stuff. WebWork is worth 15% of your grade. That's more than a test grade. That percentage-wise, that's more than a test grade. It's not an option, it's required. And to let you guys know, how many times have I seen students that basically were, just squeaking by this particular class, they made a 75 on the first test, and they made a 68 on the second test, and they made a 72 on the third test, and they made a 75 on the fourth test. So right now, they got a good 72 average going into that old final exam. Okay? However, they didn't do WebWork. They got a 54 average on WebWork because they only half did it or something like that. Well, you know what, if you look at the percentage-wise, if that's going to be 15% of your grade, do you know what happens to their grade? Their average is not 72 when you throw in WebWork like a test grade. Their average is down there in the 65 range now. okay? And if they don't do incredibly well on that final exam, then typically, how many times have I seen it that they've actually do enough to pretty much pull a C out of the class, but they didn't get the C because they didn't do their web work and their average dropped way below. And, you know, this is all about competition and numbers, and you didn't crunch the numbers right, and you end up having to take this class again. Calculus 1, Calculus 2 are C-wall classes. What I mean by that is, to be able to progress to the next level, you got to make a C or better. D and F, pretty much the same thing, except that F obviously hurts your GPA a lot worse, but having a D in this class means the same thing. You got to take the class over again. So keep that in mind. WebWork is not an option. It is required. And the way you need to look at WebWork is this. It's like a big Easter egg hunt. Every problem you do, you're just picking up points. And at the end of the semester, what we're going to do is figure out how many points you picked up, and we're going to divide by the number of points you could have gotten, and that's going to be your WebWork grade. So like I said, you've got to do it, and this is the drill, that continuous drill after class. And where most students have messed this class up is procrastination. They'll wait till the last minute, and then they're working on the web work, and then all of a sudden, zap, the thing closed on them, and they didn't finish the homework problems, and I'm sorry, I can't extend it. That's just the way it is. And then they actually end up, not doing the points, and then at the end of the semester, it just completely destroys their grade, especially at 15%. Those test reviews before each test is going to be worth 5% of your grade. Your test average is worth 45% of your grade. And in our class, we're going to have 4 tests. Pretty much chapter test. After each chapter, you guys are going to have the test. We cover four chapters, hence we have 4 tests. And then the last thing is this. We have in here a departmental cumulative final exam. What I mean by a departmental final exam is this. Everybody who's taking Calculus 1 gets to take the exact same final exam. The final exam is in 3 parts. The first part is multiple choice, no calculator. Second part is multiple choice with a calculator. The third part is free response, show your work, with the calculator. And then we basically average your grades on the 30%, 30%, and 40% on each part and stuff. And then you end up getting your final exam. And also please understand this. You guys are at an engineering school. UNC Charlotte is very prideful on their big engineering program here. And because of that, we're crunching numbers all the time from the math department's perspective. Because WebWork is not just used in the math department, it's also used in the engineering department. And so there's a couple of things that we are actually tracking you guys down on. We are tracking you guys by how much WebWork you guys do. We're looking for correlations in your studies. Everybody has to take the final exam, the same final exam. It's called a common final exam. And that final exam is on May the 3rd. I tell you to be there at 2:30, but the fact of the matter is the exam starts at 3. It's a 3-hour exam. From 3 till 6, you're taking the calculus final exam. The problem is you've got to fill out so many forms before you actually take the exam. We ask you guys to be there at 2:30, get your seat. We'll start passing out some forms. You've got to fill them out. And right at 3 o'clock, you open the test booklet. Very much SAT style type thing here. And again, at the end of this thing, we are analyzing you guys. Because remember, this is college. It's all based upon competition. How well you do versus everybody else. And that's the statistics that we're running. How well did you do? Does that correlate on how well you did with your web work? Does it correlate on how well your overall average and your final grade was in the class? And we're trying to actually improve the numbers to the next generation of students and stuff. That if you do your homework, you typically do better in class. All right, there you go. All right, again, I put the little things in here. Changing to the grade scheme may be the instructor's discretion at any time, so forth and so on. But this is pretty much what I've come up with to come up with your averages and stuff. Again, the prerequisite is a letter grade of C or better in the 1103, which is your pre-calculus class or placement test score or whatever the case may be. All right. Here is something that I got to fix. This is a new departmental directive. So I'm going to show you guys how I fix stuff. I will prove it to you. I'm going to edit here my course syllabus here. This is something coming down from the math department with us working with the engineering department. Calculators. Now I'm going to be using a calculator in here, and I'm going to be using the TI-83. Excuse me, TI-84. TI-83, 84 are pretty much the same thing. However, we will be using the TI-83/84. I'll use an 84 for this class. This is a requirement. The TI Inspire and TI-89 calculators. I'll bold this just to make it look good like everybody else. Bold. There we go. Calculators may not be used. I offer some guidance and tips on the calculator, but it's your responsibility to become familiar with your own calculator. Although calculators will be permitted in most assignments, it's very important that you always show your work, show all your work. I have a strict no work, no credit policy type thing here. Now, here's the thing. I know some of you guys may have a T89, but with this semester we decided to stop allowing the T89 in the classroom. We're only going to be using T83, 84s. And here's the reason. The engineering department contacted us during the final exam and asked us, did we see the latest app that Texas Instruments has just come out with on the T89? I said, no, I haven't seen it yet. What is it? And he said it's an app that allows you to upload PDF files on your calculator so you can view PDF files on your calculator and stuff. Well, this is one of the reasons why we didn't allow the TI Inspires, that downloadability. We can connect to the internet and to your computer and download stuff on your computer and then go watch it later. See, our problem with this is, okay, well, you got your homework set, which we just covered, and so you've got all the answers on this thing. Now you can scan that sucker in as a PDF file and you can have it on your calculator, and now you can use your calculator to go view this thing during a test. We call that cheating. So the only way we can avoid cheating or any kind of the look of cheating and stuff like that is actually just not allow that calculator. So starting this semester, the math department has made the decision because, you know, the only other thing we can do is grab everybody who has a T89 calculator and go take their calculator and make sure that app is not actually on their calculator. I don't want to do that. No professor wants to sit there and kind of go through your stuff to see if you've got something illegal on your calculator or not. So we decided as a department, no more T89s. So, and in semesters past, yeah, as you can tell, we did use 89s, but it's this new app that just came out with Texas Instruments that you pretty much download off the internet that allows you to actually store features and stuff. No, sorry, you guys messed it up. Sorry, no more T89s. Attendance policy. This class does have an attendance policy, and attendance will be taken at every class. This is one of Katrina's big jobs here. And so we will be having assigned seats. Now, obviously, this is the first day of class, so nothing major yet, but down the road, we will be having assigned seats. This is a directive coming from the UNC System School out of Chapel Hill. So all 17 campuses of the UNC System School must adhere to an attendance policy. And this is my attendance policy. So watch this. You'll enjoy it. Students with 3 or fewer absences will not be required to submit any documentation, and there will be no penalty. So you can have up to and including 3 absences. Here it comes. Students with 4 or more absences will have to submit acceptable documentation to the Dean of Students for each absence. So once you get 4, you've got to go back and actually, remember that when you missed on February the 3rd? Oh, dude, you got to go back and put the documentation into the Dean of Students for that particular miss and all the other misses that you happen to have. You know, it's a pain, so that's why we're trying to do this. So to avoid actually getting 4 or more absences, again, from the Dean of Students. Obviously, if you've got the flu or something or other, keep your doctor's note, stuff like that. Submit it to the Dean of Students. You'll get acceptable excused absence there. Each unexcused absence will result in a student's final grade being lowered by 5%. Okay? So, you know, again, I'll let you guys know, your students before you guys have screwed it up. We had a competition in the math department between myself and a few other math professors, and we were trying to decide which attendance policy is better? To give points for good attendance or to take points away for bad attendance? Guess which one won? You can't give, I don't know, maybe the 21st century. You can't give students anything. They won't go out of their way to go get free stuff if you just gave it to them. But you start taking points away, all of a sudden my classes are full. Okay? So because of that, I won the math department award for coming up with the idea of, yeah, it's better to take away points than it is to give points. Because a lot of students won't cross the street to pick up a few points on their average. I don't understand that. But man, you start taking away points off their average, all of a sudden they are Johnny on the spot in terms of coming to class and stuff. So, but here's the deal. Here's another thing too. At the end of the semester, I always have a bunch of students. Now, granted, I have large classes, so when I say a bunch of students, I really mean a bunch of students too, that want to ask me, Dr. Taylor, I'm awfully close to that B or that A or that C. But I could really use some bonus. Could you give us some bonus? Well, number one, what are you actually asking me to give you a bonus? Do you want me to create a new homework set for you so you can turn that one in? Why would I want to do that? You haven't turned in the other 4 homework sets. Why am I going to do a special homework set for you to turn that thing in? Well, that doesn't make any logical sense from a math professor perspective. So I don't give extra homework sets. I got enough crap to grade in this class. I don't need any more stuff to grade. However, I do give bonuses, but my bonuses are linked to attendance. So I did kind of take some of my other professors' idea about, extra points being given, but I only give it for good attendance. And here's the thing. In addition, incentives will be rewarded for good attendance. Students with 2 or fewer total absences may earn extra credit and qualify for bonus grades throughout the semester. You should be absent. Should you be absent for any reason, it is your responsibility to catch up and get the notes. A Panopto video will be posted for you, and learn the material on your own. You're responsible for any announcements made during the class, and will not be exempt from any assignments. Due dates or missed announcements are due to your absence. So my point is there's going to be some bonus at the end of the semester. So, but I'm going to link it to attendance, because and it's like, again, semesters in past, the folks with the good attendance typically are doing well, and I'm going to make sure that if there's any kind of little bonus thing, you'll be eligible for that particular bonus as well. But it's going to be based upon attendance. If you got poor attendance, you're really shooting yourself in the foot. Not just because you're missing out on the material, and this is a class you can't afford to miss out on. You're also going to be missing out some extra points at the end of the semester. Never miss class for any reason. This is paramount. Now, with this class, I know I have a bunch of freshmen in the class and stuff, and we're having to basically rewrite your thinking about stuff, and let me explain it to you very distinctly. This is college. I know a bunch of you guys, and you guys tell me this stuff all the time. Dr. Taylor, I've never missed a day of your class. I don't understand why I'm failing. Dude, you haven't passed a test all semester long. Yeah, but I did this in high school and my teacher always passed me. Well, your high school teacher must have been an idiot. We're a college professor. This is college, and it's all based upon competition. It's you versus everybody else. You've got to know this material. I cannot pass you. If you guys don't know Calculus 1, it is a crime for me to give you that little bump up into a C to put you into a Calculus 2 class, because you'll never pass it. And same idea as you work up the line. Calc 2, pass you up to Calc 3, pass you up to differential equations, linear algebra. There is a large ladder you've got to walk. And all along the way, you're learning material. And if you've got a gap in any of that stuff, you're going to fall off that ladder. But you've got to be here. You can't afford to miss classes. You've got to understand this stuff. And again, Katrina will back me up in terms of this. She's a senior now. She's trying to graduate, maybe, and try to go to graduate school. God help her. So the fact is, seriously, you got to know this stuff because as you go through more and more classes, you're going to be continuously using this material that you've learned in this class and the next class up and so forth and so on. So, and again, I'm going to kind of go through the rest of this kind of lightly. Communication policy. Basically, I use Canvas to communicate with you guys. Also, email if you need to email me back on something or other. But so you need to check your Canvas site daily, because I'm always making announcements, especially on that front page. And also, I typically will sometimes change dates and stuff like that as we go through the material. So any kind of dates I have on our syllabus are tentative dates and stuff. Okay? And here's some information about when you email me. Certain emails we were not responsive to. So kind of read through this on your own in terms of appropriate emails and things like that. Review sessions and tutoring. We've got a lot of help for you guys. We have across from the math department called the Math Resource Center, Math Learning Center. You go there. It's open tutoring. We're also going to have SI sessions. We also have one-on-one tutoring at the University Academic Excellence Center. And so there's lots of ways to get some extra help out of stuff. And I will be posting all this information on our Canvas site. Makeup and late work policy. Big deal is this. As I mentioned to you guys that I recorded this material. So when I actually give you guys a homework set and it's due on a certain day, typically that Friday at the review session type thing here, what I'm going to do is I'm going to take time, I'm going to do that review set, and I'm going to put it up here, and I'm going to do every question for you guys. I'm going to show you how I got the answer and what you should have done on the particular homework set. And then I immediately, right after that class, I'm going to post it. So basically, I am posting the solutions in video form. And because I do that, I cannot accept any late homework because I've already given you guys all the answers. Watch the video. That was kind of the point. So I don't accept late homework. But we have due dates, and it's due by that time. You've got to get your stuff in by that time. In terms of makeups and stuff like that, comes a test and stuff. Now, yes, I'm a nice guy. If you had the flu or something or other on the day we're about to have a test, first things first, you should email me the day before the test to let me know that you have got some kind of ailment or something or other. You've got to get documentation for it, university policy. Go through the dean of students and let them confirm all your documentation stuff. And you do both those two things, we'll make a plan for a makeup test or something or other. The ones that bother me are the ones that, 3 days after we had the test, they shoot me an email or come by my office. Oh, by the way, I missed a test. Can I get a makeup? The answer is no. You get a 0 for that. You've got to let me know the day of the test or before the test type thing here. You understand? Don't come to me 3 days later and say, oh, by the way, guess what I didn't do? Take your test. No, then you didn't do it in the proper procedure thing. So, all right. Tardiness. You're expected to be on time and stay until the end of every class. Arriving late or leaving early will be counted as absence. Academic integrity. Here is the website for the official UNC Charlotte don't cheat, don't be dishonest thing here. Assignment standards. Take pride in your work. When you turn in something or other, staple it, be neat, be organized. Don't sit there and punch a bunch of papers into me and you got page 5, then you got page 1, then you got page 2, and you got scribble all over the place. That's, we do great on partial credit if we understand it and can follow P implies Q on the darn thing. So it's got to be neat, it's got to be organized, and you should always staple appropriately, in order of the papers and stuff like that. Always use pencil, so forth and so on. Okay, electronic devices. You have to turn off and put away all electronic devices. The only kind of electronic device you're allowed to have is a calculator on your desk. Now, if you're one of these students that have one of these tablet PCs type thing here that you can actually write on and take notes, that's fine because you can flap that thing down and actually write it with your little stylus and stuff. I'll accept that. That's fine with me. I'm okay with that. But I don't want to see any laptops in this class for several reasons. Number one, when I see a student with a laptop, all I typically see is the top of their head because they're buried into their computer. Number two, it's a distraction. Not for me because I know what I'm doing up here. it's for the students sitting around you, okay? Because I'm trying to get everybody focused on this material. And if you got some interesting website you shouldn't be watching during my class, one, it's rude. Number two, it's probably funny. And all your friends around you are going to want to watch this thing too. And if they're watching it, they're not watching me trying to do math problems and stuff. So you're not only killing your own grade, you're killing people around your grade. And I cannot accept that. So therefore, no laptops in class unless it's one of the little PCs that you can actually flop down and stuff like that on. And it's basically, we're a math class where we're working on math. Disability services. Here is, if you are needing of those or are eligible for this, here's their phone number and their office. Fretwell 230. Please go into and talk to those guys and get the appropriate forms and stuff. Calculus 1 expectations, so please read through this. For every hour you're in class, there's between 1 to 2, at least 3 hours of homework to be done for every class. I mean, this is a big class, and it's important, especially for your major. You guys are in Engineering Calculus 1, 1241, which means you're a STEM major typically, which means you got one of the harder majors out there to have. But don't worry, the whole goal of life is it'll pay for itself when you graduate and down the road and stuff. This is why you're in this class, and we understand that. But it is tough, which means you're going to have to spend the time on this particular material and stuff. So be prepared, arriving with your notes, calculator, positive attitude, complete the after-class activities in a timely manner before the due dates and stuff like that. Also, when you need some tutoring help and stuff like that, don't wait till the last minute. Go out and seek it out now and stuff. Okay. So you can read through the rest of these things. I'm just trying to actually just give you guys some kind of general idea and stuff like that. And down here, I've got some WebWork and quiz due dates and stuff like that, and I will change those accordingly and stuff because we're still working on our little website and stuff. The other big thing is this. Okay, when you come over here to your modules and stuff, well, you guys have a computer WebWork thing here. Now, because of security and stuff like that, it's pretty much one-shot login. You log in on Canvas, and then, all right, so I'm going to come over here, and you guys have a homework set due for me. Let's see, here's one right here. WebWork Chapter 1 Review. Let me click on this thing here. When you guys go to this thing and click on it, it'll give you an icon to click on. Load a WebWork, WebWork, Chapter 1 Review in a new module, in a new window. So I click on this. It automatically logs you in through your qualifications in Canvas site, so you don't have to log in again. It'll automatically log you in on WebWork. But you need to go ahead and log in, get on your Canvas site and log into WebWork now, because that first time you log in, it's beginning to store all your information, and then it actually has all this stuff in there. So it's very synced in with Canvas site. So you got two different computer systems working together, Canvas and WebWork, and they're communicating. So when you log in to WebWork, it's also going to, at the end of the day, so here's another deal too. I'm going to do a bunch of problems on this thing, okay? However, at the end of the day, if I go back and do a bunch of homework problems and I go over there to the Canvas site and look at my grade, your grade's still going to be a 0. You go, wait, but that can't be right. I made 100 on everything. I should get 100 on this thing. No, the two systems interact at about midnight every night. So when you've done a homework set during the day, it won't automatically upload to Canvas. It'll be the end of the day when WebWork will upload it back to Canvas, and then the grades will update and stuff like that. So don't be upset when you're doing a bunch of homework problems and your grade doesn't change immediately. You got to wait till pretty much midnight before the systems link up again and stuff like that. All right. So let me tell you about WebWork. Here's WebWork. Once you're signed in, you will come over here and pick a particular problem. Let's see here. I didn't do number 6, so let's click on number 6. See if we can do this. All right, here's this problem here. As I mentioned to you before, WebWork is pretty much a computer system. This is all algebra review, so you're supposed to know this problem anyway. And here's the deal. It's like a big Easter egg hunt. I'm just trying to pick up points all semester long. Every question is typically worth 1 point. So I got 3 questions on this one, so I got about a third of a point to get my full point on this thing here. So let's see if we can do this one. Starting with the graph of f of x equals 9 to the x. Write the equation of the graph that results from shifting f of x 4 units downward. What would y equal if I shifted it down 4 units downward? This is called techniques of shifting, stretching, reflecting that you guys did way back in pre-calculus, college algebra stuff here. So if I'm going to give the entire function 4 units downward, I'm going to take my function, which is 9 raised to the x. But how do I shift it down 4 units? Minus 4 at the end. It's called a vertical shift. Minus 4 drops it down 4, plus 4 drops it up, raises it up 4. But what about this one? Shifting f of x 3 units to the left. Now, left and right is a horizontal shift. And you got to remember, horizontal shift have this opposite effect. So if I want to go 3 units to the left, most people think left would be what kind of number? Minus, but it actually is going to be plus. And horizontal shift is inside the parentheses where the x is at. So notice I'll use parentheses here. It'll be 9 raised to the parentheses x. Let's see here. 3 units to the left, that'll be plus 3, close parentheses. You with me? Now, what about this one? You want to reflect f of x about the x-axis. When you reflect about the x-axis, it flips the graph upside down. What operation has an effect of flipping the graph completely upside down? Negative. Multiplying the function by -1. So you can do this. -1 times, or just negative if you want to, that function 9 raised to the x. All right. Now here's the thing. When it comes to WebWork, we don't care about the number of attempts. Most problems we have unlimited attempts. At the end of the day, what it's really all about is making sure you get credit for it, getting it correct. So to get credit, what I'm going to do here is I'm going to submit answers. I click on submit answers, and what do I see? Nothing but UNC Charlotte Green. Correct, 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 all over the place, which means I got this problem correct. I just got 1 more point added to my WebWork grade, and 400 points later, hopefully I'll get an A on this particular material and stuff like that, because there's lots of WebWork problems you guys have to do. But let me go back over here, back to the review chapter. Let's pick another problem. I've done several of these before. Let's see here. Number 15. Let's try this one. Oh, no, graphing thing here. All right, random boys here. This is called composition of functions. The bold graph is g of x. The big little check-looking thin graph is f of x. And our job is to find f of g of -2. What does that mean? Order of operations. I work inside the parentheses first. I want to do g of -2. Well, here's 0 right here at the origin. -2 would be over here. G of it would be the y-coordinate 1, 2. You with me? So g of -2 is positive 2. So this f of g of -2 would be the same thing as f of 2. Here is your f graph. 2 is right here. F of 2 is actually what? So the answer would be -2. Order of operation. You work inside the parentheses first, then outside the parentheses. Okay? What is f of g of -3? Well, g of -3, there's -1, -2, -3 would be 1, 2, 3. And f of 3, here is 2, 3. F of 3 is what? Very good, 0. What is g of f of 3? Well, f of 3 was what again? 0. And then g of 0 is what number? 1. It's 1 hash mark up. So it's 1. What is f of g of 2? F of 2, excuse me, f of g of 2. G of 2 is what number? 1, 2, 3, 4, 5. So this would be f of 5. Here is f of 5. That would be 1, 2, 3, 4, 3, 4, 5. And f of that one would be 1, 2, 3, 4, it looks like. This would be 4. Oh, and here's the ones that mess people up. What's f of 4? What's f of 4? Well, here's 4. 1, 2, 3, 4. F of 4 is 2. And then I got to do f of that. So an f of 2 is negative 2. And what is g of f of 4? Again, f of 4 was what now? Here's 2, 3, 4 is right here. 1, 2. So f of 4 is 2. And g of 2 is 1, 2, 3, 4, 5. Do you agree? Okay. But I'm going to make a typo. I made that one 4 at the end. And I'm going to submit answers. Oh, and I got one wrong. Which means I got to go back and do that one again. Oh, yeah, it wasn't supposed to be a 4. It was a 5. 5. And then I hit submit answers. Okay. And now there's all my UNC Charlotte green. So when I come over here to your chapter 1, you're going to see over here, what was that problem number? What was it? 15? You'll see that I have 2 attempts. Don't care. What I really care about is that status right there. What is that? 100%. That's what I want. Okay? Because this is a computer system. Sometimes it's tough to count some of those hash marks, and I can make a careless error. Also, there's a lot of function stuff you guys have to type in. And you know if you put the parenthesis in the wrong spot, it's going to screw up the whole thing. We don't typically care about the number of attempts. There's a few problems on WebWork. We are going to make you guys care about number of attempts. You know, true, false questions. Think about it. True, 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 true. Oh, 1 and 3 are wrong. Really? Okay, false, false, I'm done. No, you have only 1 attempt on true, false questions. So there, we can limit the number of attempts. But most of them, we just give you guys unlimited attempts because it is a computer, and it's if you don't put something in the right spot, even though it was a typo type thing here, that you shouldn't be deducted points for that. So we give you guys unlimited attempts. But so here's welcome to WebWork. Go ahead, get on it. Go ahead and log in and start working on your homework sets and stuff. All right. So if we come back over here to WebWork and back to modules, what does our course syllabus say we're supposed to do today? Now, this is the course information. This is the prerequisite information. And that includes chapters 1.1 and 1.2 out of your textbook, which is nothing but algebra review questions. Just like the problems we did, that was where we're 1.1 and 1.2 are going to be just like more algebra review questions type things here. And the 1.2 web work, I actually did the notes, 1.2, part 1 and part 2, I did those actually on a video for you guys. So if you're supposed to, go over here and print out your notes, and let's see here, under course requirements, there's my notes right there. I printed out mine already. And so according to this, today I'm supposed to start section 1.3. So you should have, before coming to class, yeah, I know it's the first day of class, but hang with me. First, before coming to class, you should have watched this awesome video some professor did for you guys, and then taken the quiz. But because this is still drop add, I'm not making anything due until after drop add. So go ahead and get the pre-section video done. Make sure you take the quiz. Go ahead and get your points for that. And then come to class. And then after that, you can go ahead and start your WebWork 1.3. So I'm going to come over here and show you the notes. Here are our notes. Okay? Now, this notes start with section 1.2. Here is our goal. If you notice on the preview section here, I had a video for section 1.1 part 1, and 1.2 part 1, 1.2 part 2. I actually went through this thing with you guys, so I'm not going to do this in class because this is algebra review with trigonometry and stuff. Things you're supposed to know, I'm just trying to remind you of these things. So, section 1.3 is where class starts with. And if you look through the notes and stuff, you'll also see pretty darn close to the exact problem I just did a few seconds ago. I did make this stuff kind of linked to your WebWork stuff. But here is section 1.3. All right. This is where calculus begins at. It is called limits. Okay? Limits. Definition. take the limit as x approaches a of f of x equals L. This is how you read it. The limit of f of x as x approaches a equals L. In English, what this really means is where is the functional value headed as x is quote-unquote on its way to a. Okay? So we're trying to do limits. Now, you have something like maybe this. Well, you got a function with a hole in the graph. And here is a right there. Now, limits are different from functional values. So when I ask you what is the limit as x approaches a of f of x, I'm asking you as you get very, very close to a, where is the functional value? Okay? The problem is the functional value is a hole in the graph. There is no functional value for this guy. But as you get very, very close to a from below and from above, what number are we approaching? Well, this hole in the graph is at some kind of L number, and that is my limit number, L. Okay? So, and to describe a full limit, you have to take the limit as x approaches a from below, and the limit as x approaches a from above. So, when I take the limit as x approaches a from below, we put a little minus sign behind a. Not in front of it, that makes it negative. This little minus sign is behind a of f of x. And what we're asking you is, here is a. As you approach a from below a, where is my functional value going? So if this is my function here, this is going towards the open circle, which is at L. However, if I take the limit as x approaches a of f of x from above, and that's a little plus sign there, from above a, then the function's up here, and at a is where the break is at, but this would be at maybe some number m. It'll be a different number. This is the limit as x approaches a from the right. This is the limit as x approaches a from the left. And the definition, for a full limit to exist, the limit from the left has got to be equal to the limit from the right. Otherwise, we say the answer is does not exist, no solution. Okay? Now, in our notes, we do this just because we want you guys to have a truly complete set of notes. Remember, before each section, you're supposed to watch a pre-section video and then take a quiz on it. Well, I've taken those pre-section video questions that I did and I typed them up for you guys on this thing, and I put the word video on there. So I don't typically do these problems in class because I did them on the video that you guys are supposed to be watching. So the ones without the videos is the ones I'm going to do. Now, this is the idea behind the limits. Okay? Let me give you an example so you guys would understand this stuff. Let's say I happen to have a circuit. I input amps and the output is volts. Okay? So I got a circuit and I got this little machine beside it, and so I can put some electricity through this thing, and I can regulate how many amps I'm putting through the circuit. Here's my problem. Every time I hit 5 amps, my circuit blows up. Fire, death, people die, it's awful. 5 amps, this thing just blows up. So I go out and build another one, just like it, and I got to figure out what's going on at 5 amps. This is where limits come in at. Because 5 blows up. So what am I going to do to figure this thing out? Well, I'm going to start off my circuit. I'm going to crank it up. I'm going to put in 1 amp, 2 amps, 3 amps, working fine, 4 amps, working fine. Then I'm going to try 4.5 amps, working fine, 4.6, working fine, 4.7. It's beginning to shake, a little smoke, but still working fine. 4.8, a little more smoke. 4.9, a lot more smoke, but no fire yet. 4.91, 4.9, 4.99, boom, okay. This is the idea behind limits. I'm getting very, very close, and I'm monitoring what's going on until I get to my problem point. And then I can basically, that's the idea behind what we do with limits, getting that incremental approach. But here's the deal. When you actually have a function, mathematically, of a function, take the limit as x approaches 3 of x squared, first thing you do is you look at the function. Is there a problem at the point? In this case, it's 3. If there's no problem, the first rule of limits is plug in the number. So, look at this one. What is the limit as x approaches 3 of x squared? Well, x squared is a nice little parabola. There's no problems with x squared. There's no holes in the graph. There's no, breaks in the graph or anything like that. So first rule of limits is plug in the number. Since there's no problem at 3, you're going to get 3 squared, which is, your limit is 9. The functional value and the limit value are going to be the same thing when there's no problem. Same idea here. Take the limit as x approaches 1 of 1 over x. Now 1 over x has a problem. Where's my problem point with 1 over x? 0. You can't divide by 0. But that's not the number we're approaching. What number are we going after? 1. So when I take the limit as x approaches 1, which is not my problem point, first rule of limits is plug it in. This is going to give me 1 over 1, which is 1. Answer is 1. First rule of limits, plug in a number. If you get a number, you're done. Okay? The next one, however, is something that's, again, very important. This is called the factor multiplication and then evaluate method. Factor the expression, cancel any common terms. And I did a couple of great problems actually on the video. Please go watch the video and take notes off the pre-section video here. Now what we're really talking about is this. It is called an indeterminate form of 0 divided by 0. Let me explain. We just said a few seconds ago, I can't divide by 0. That's a violation of mathematics. You can't divide by 0. But what if it is 0 divided by 0? We call that indeterminate. And the reason we call it indeterminate is this. Well, 5 divided by 5 is 1. 0.5 divided by 0.5 is 1. 0.1 divided by 0.1 is 1. 0.01 divided by 0.01 is 1. So is this thing going to cancel and give me 1? Is it because the numerator is 0? Maybe the answer is 0 because 0 divided by anybody is 0, right? So maybe the answer is 0. Or when I divide by 0, maybe it doesn't exist at all. Well, and all three of those answers is possible. This is why we say it's indeterminate. You can't tell. So when it comes to limits, first rule of limits is plug it in. And if I get a 0 over 0, you were supposed to, here it comes, doesn't take very long in a calculus class, do algebra. Hopefully something will cancel. Algebra doesn't always work, but most times it does. Take a look at this example here. I did these two guys on the pre-section video. I want you to go back and watch the pre-section video and take notes off of it. So I'll do this one here. Take the limit as x approaches 4 of x minus 4 divided by x squared minus 16. First rule of limits is plug in a number. So this is going to be 4 minus 4 over 4 squared minus 16. Well, 4 minus 4 is 0. 4 squared is 16 minus 16 is 0. So this is a famous 0 divided by 0 indeterminate form case. So this would be equal to the limit as x approaches 4 of, do algebra. Well, I look at that numerator, that term. I got x minus 4. There's not much algebra I can do with that. There's nothing in common or anything like that, so I'm just going to leave that one alone. X minus 4. But now look at the denominator. It is x squared minus 16. What kind of algebra can you do on this thing? And remember, ultimate goal with 0 divided by 0 is to get somebody to cancel. And you cancel through strict multiplication division. So what can you do with x squared minus 16? Get factors. It's called a difference of squares. So x squared minus 16 factors into x plus 4 times x minus 4. And through strict multiplication division, you can see the x minus 4's cancel. So this is equal to the limit as x approaches 4 of, the entire numerator cancel, but you always have 1 for placement, 1 over x plus 4. So you've cleaned up this thing through algebra, and now, like back to the first rule of limits here, plug in the number. So this is going to give you 1 over 4 plus 4, so the answer is 1/8. Now, listen up and listen good. Calculus is not just about getting the right answer. It is also about showing your work on how you got the right answer. look at the work that I did on this problem. First thing I did was take my problem and I plugged in the number. When I plug in the number, I don't write limit anymore. 4 minus 4 over 4 squared minus 16, 0 over 0. And then I decided I had to need to do algebra on this thing. So this is equal to, and doing algebra, I rewrote the limit as x approaches 4. I didn't do much on the numerator, but I factored the denominator. I canceled, and I rewrote limit as x approaches 4 of the resultant after canceling 1 over x plus 4. And then what do? Well, once I clean it up, and then I plug in the number. When I plug in the number, I don't write limit anymore. It's now 1 over x is 4, 4 plus 4, and I get 1/8, and I circled it. It's not just about getting the answer. It's about how I wrote it up properly to get that answer. Keep that in mind when you're doing calculus. Take a look at this next guy. Take the limit as x approaches 3 of x squared minus 3x divided by x squared minus 2x minus 3. Well, again, first rule of limits is plug it in. This will be 3 squared minus 3 times 3 divided by 3 squared minus 2 times 3 minus 3. 3 squared is 9, 3 times 3 is 9, 9 minus 9 is 0. 3 squared is 9, 2 times 3 is 6, 9 minus 6 is 3, minus 3 is, oh, what a surprise, 0. So, notice I didn't write limit, I just plugged in a number. Let's see what's going on. Because if I got a number out of it, I circle it and I'm done. That's all the work I needed to do. But this one is 0 over 0, indeterminate case. So now I'm going to rewrite limit as x approaches 3, and then I need to clean it up. Again, we want to cancel stuff out. The 0 over 0 leads into this idea something should cancel. To be able to cancel, you've got to have strict multiplication division so things will cancel. So I want to factor is going to be the big word here. What can I factor out of x squared minus 3x? I can take out an x. That leaves me with x minus 3. What about that x squared minus 2x minus 3? That's a classic trinomial anti-full thing. X. What times what is 3 that differ by 2? Got to be 3 and 1. And since it's minus on the back, they're opposite signs. Since the middle term is negative, the bigger number is negative, the smaller number is positive. So it factors into x minus 3 times x plus 1. What cancels? The x minus 3's cancel. So what's left? Keep writing the word limit as x approaches 3 of x divided by x plus 1. And then, what am I going to do once I clean it up? Plug in the number. Once I plug it in, I don't write limit anymore. This is 3 over 3 plus 1. So the answer is 3/4. Understand what's going on here. If you go and actually graph this function x squared minus 3x divided by x squared minus 2x minus 3, you're going to get some elaborate graph. However, if you go and analyze that graph right at the point 3, you know what you're going to get? A hole in the graph. Because officially, you're dividing by 0, which doesn't exist. So right at that point, there's a hole in the graph. So when I'm doing the limit as x approaches a number of whatever function here, and I'm getting 0 over 0, that 0 over 0 traditionally tells me there's a hole in the graph. And when I evaluate the limit through the algebra stuff, it's telling me what's the y-coordinate of the hole in the graph. In this particular function, there's a hole in the graph at the point 3, 3/4. The y-coordinate of the hole in the graph is actually 3/4. 0.75 for you engineers out there. Does that make sense? Did I lose you guys anywhere? So this is an important concept called limits, and we're going to beat this to death in the rest of Chapter 1. So study hard. Go get on that website. Go ahead and start doing the pre-section videos and WebWork. I'll see you guys on Thursday.